Okay, so we're going to have a real quick lesson here on identifying prime and composite numbers. Okay, so it's TEAC 5.4a. Identify prime and composite numbers. Okay, so mainly it's some vocabulary that we need to understand here. So the first one is factor pairs. And we've been talking a lot about factors and factor pairs the last couple of days. So by definition, a factor pair is a pair of whole numbers that make another whole number. Okay. A pair of whole numbers that make up another whole number. So let's say we have the number 24. So its factor pairs would be 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Those are the factor pairs for 24. Okay, so now let's go ahead and define those prime numbers. Okay, a prime number is a number with only one factor pair and that factor pair is 1 and itself. So for example, 13. Well, the only way to make 13 is 1 times 13. Nothing else will make 13. You can't do 2 times 6, that's 12. Okay. How about the number 3? The only way to make number 3 is 1 times 3. Those are the only factors for the number 3, 1 and itself. So therefore 3 is a prime number. number 7. The factor pair for number 7 is 1 and itself. 1 times 7. That's it. That's all that makes 7. Two times 3 is 6, but 2 times 4 is 8. So we missed 7 altogether, right? So those are your prime numbers. They only have one factor pair, and that is 1 and itself. So those other numbers are called composite numbers. Composite numbers are numbers that have more than one factor pair. Okay, so some examples of those would be, how about 6? We have 1 times 6 and 2 times 3. So there was 2 factor pairs for 6, making 6 a composite number. 9, 1 times 9, and 3 times 3. Another composite number. How about 10? 1 times 10 and 2 times 5. And let's see, how about 12? Well, there's 1 times 12, 2 times 6, oh, and 3 times 4. So 12 has 3 factor pairs. 12 is also a composite number. Well, here's 15. 1 times 15 and 3 times 5. So 15 is a composite number. It has 2 factor pairs. Now I want you to notice that I have 2 odd numbers here that are composite, right? So remember, just like I've said in class, just because a number is odd does not mean it is prime. Okay? I have 2 examples here of odd numbers that are composite. Okay, now let's talk about square numbers. Square numbers are the product of a number times itself. So, what do I mean? Well, 4 is a square number because it is 2 times 2. And we write that 2 with the little 2 above it, 2 squared. "16 is a square number because it is 4 times 4. And we write that as 4 squared. "9 is a square number because it is 3 times 3, or also written 3 squared. And 100 is a square number because it is 10 times 10, or also written 10 squared. Can you think of any other square numbers? All right, well, that is it for today's lesson on prime and composite numbers.